So I would like to introduce Dominic Muren. Dominic is a prolific designer, writer, and critic. He founded the popular industrial design blog idfuel.com and served as contributing writer for Tree Hugger, which also called Green CNN. His writing explores the interconnections between design objects, the environment, and society, the tricky, complicated factors that make products work within different systems. His most recent book, Green, Not Black and White, The Balanced Guide to Making Eco Decisions, has been reprinted in 6 languages. He's been awarded 2010 TED Global Fellowship for his work on Humblefacture, which is his website, on involving manifesto which argues that bringing factories down to local accessible scale, manufacturing can be made more environmentally, socially, and functionally possible. In addition to his writing, teaching, Dominic is award-winning industrial designer, and his design laboratory in Seattle, Washington is work in progress Humblefacture, and his blog humblefacture.com is a place to look. The reason, also another reason he is here, because this semester, environmental design class that I'm teaching and Dominic's class in Seattle, we doing same project remotely, comparing the results. It's an experiment that goes east-west coast, locally produced, manufactured objects, and something that we take into New York for ICFF in May. So just, follow us and see what's happening. It's something excited here at Micah, and let's welcome Dominic.
All right. Thanks very much, Ina. So, I'm really happy to be here. Thank you so much for having me. And I'm really excited about Baltimore as a city, right? I spent a lot of time in Philadelphia in graduate school, and Baltimore has a very similar flavor to Philly as far as the history of making the stuff that sort of made America. Seattle, not so much. We sort of chopped down the trees that made America, but we didn't actually manufacture a lot of things until sort of the 70s when we started making all the airplanes for the US. And so I'm interested in that kind of tension between those 2 places, and that's part of this broader idea that I have, which is Humblefacture, which is trying to think about how you can make better designs using clever design, like better objects using clever design rather than using a whole bunch of energy. And I'll get into that in a little bit. So to start, it's important to remember that humans are really tool users, or you could think of us as we don't really exist without our tools. We don't have really nice claws or feathers or, hard shells to protect us or something like that. And so we have to wear things like clothes and use things like hammers and nails and laptops in order to help us do things better than other animals and sort of successfully compete in the world. We used to have really simple tools like digging sticks, right? The most sort of primitive tool that you can plant things with. And this is a woman in Ethiopia planting with a digging stick, planting some manioc or tubers or something. Digging sticks got a little more complicated when we sort of designed them into a slightly more complicated version. And this is basically a digging stick that's pulled by oxen, right? So it's this sort of simple plow. You can get a little more complicated by integrating different kinds of tools, right? Or different kinds of materials like steel. So now you take that plow idea and you mix in some steel, and now you have the sort of traditional horse-drawn plow. This one's being operated by an Amish guy in Pennsylvania Dutch country, but this tool was really important for humans for a long time until we thought about another manufacturing method that would allow us to make not only more complicated multi multi-blade plows and plow more land at once, but also to make sort of mechanical horses, right? So we're getting more and more complicated designs as we move along. Finally, we end up with this system where modern plows are unbelievably complex and plow massive amounts of land at once, and they have air-conditioned cabins, and they're GPS controlled, and all of this stuff is really great, right? Because it allows us to have agriculture where you have very few people involved in agriculture compared to the one person digging the one potato with the one stick. But the problem with that is it becomes really difficult for everyone to have access to these tools, and there become these consequences that you didn't think were going to be a problem. You thought it would be great to sort of create this tool that was super complex, that was super powerful. You end up with complexity being really key to the way that these things work, to the functional utility that we get out of our tools. And that complexity allows, the same matter, so silica in this case, or silicon, to be reformed from something that's like a really primitive tool, like a celt, like a stone hammer, to a piece of RAM in a computer, right? These are the same, it's the same atoms, it's the same matter, but given a very different shape, it performs a different function, right? So that complexity is actually the difference between this hammer and this RAM chip. And I want to really drive that home, that the complexity is the difference. It's not the matter, it's the complexity. And the way that you get that complexity into the matter is sort of what matters, right? That's the thing that's important. You can get it in via really high energy methods, which is what we sort of do with this silicon, or you might be able to get it in via other methods. So now here's another example. This is the oldest shoe on the left. It's from Armenia. It's about 6,000 years old. The oldest shoe that obviously there were shoes before this shoe, but this is the oldest one we've dug up. And then this is a sort of slightly older shoe. This one is from the Smithsonian, and it's about like a couple hundred years old. And then there's a very sort of high-tech, New Balance trainer on the right there. And that progression, right, from a simple leather sock stuffed with straw to a shoe composed of probably 50 or 60 different components, all of them with different material properties, all of them with different complexity, right, allows one of the shoes to sort of just protect your feet, and one of the shoes to allow you to run a marathon without dying, like the first guy that ran a marathon, right? And so that's a big difference. That's a big change, and that change comes from the complexity, right? The difficulty that we have, the difficulty that we find ourselves in, is that the way that we currently put complexity into matter to make really nice products comes at a cost. And it comes at a pretty high cost. And it comes at various costs. And so I want to sort of enumerate some of those costs so we're all on the same page. The first really obvious cost is this energy, right? So most matter making that we do, or most matter complicating that we do, we sort of either heat, we do this process called heat, beat, repeat, right? So that's what metal workers talk about, heating and beating material. And so you heat up the material, you squish it into shape. Then you heat it up and you squish it more into shape. And eventually you get it into the shape you want with the material properties you want, right? And this is fine, but it's sort of an inelegant way to inform that matter, because you waste a lot of energy, you create a lot of waste, it takes a lot of time, it takes a lot of effort, right? Another way that we do things is to cut and carve. So this is sort of the woodworker's method for making stuff. And this introduces this cost of waste, right? Where if you want to make a bowl that's this big and made out of solid piece of wood, you need to cut away all of this material inside the bowl. And that all becomes waste, right? And the reason that it becomes waste is because of the way you decided to make the bowl. What you really wanted was a form that had this shape, and if you had maybe molded it out of paper or woven it out of strands of wood, you could create that bowl with less waste, but you had to do it with a sort of more complicated design, right? And so I'll go into some methods by which you can avoid waste. There are some other costs, though. Access is a big cost, and this is one of the ones that's really becoming obvious and important to people now, especially after the sort of tech boom. We're realizing that when people have access to cheap tools for writing code and to cheap ways for getting code launched, so for example, distributing via the internet versus distributing via a CD-ROM or a floppy disk, you can get a lot more people to buy your iPhone app, for example. You know, you can write an iPhone app in a weekend and you can make $100,000 in a week by launching that thing, and you didn't have to physically send any stuff out, right? So that access really makes a very vibrant, interesting economy. The difficulty with access from making objects is that most of the tools that we've developed over those 150, 200 years since the Industrial Revolution, most of those tools are relatively large and expensive. And so you need to have a lot of space in order to house those tools, and you also need to have a lot of money in order to purchase them. And part of that's tied up in the sort of corporate structure of companies, but part of that is just tied up in what kinds of tools we've been working to develop. We've only really been working on these large-scale tools for large-scale companies because that's who's been demanding them. So that access is a key point. Because of that access, we sort of lose representation within the system. So because you have to have large companies that are centrally located with those big tools and big spaces, you don't have a manufacturer of clothing or a manufacturer of, say, iPhones. This is Foxconn in China, which manufactured your iPhone. And you may notice these nets strung up around the building. The reason that these nets are there is because they have such a high rate of suicides that they actually installed suicide prevention nets. This is like recently, within the last 3 or 4 months. And it has successfully curbed suicides via jumping off the building, right? So sort of a good solution, I guess, that, I mean, obviously something's wrong, and the nets are only keeping people from being able to kill themselves that way, right? Probably the something that's wrong has to do with this company making iPhones the way they make iPhones, you would assume, since they're only, it's a bunch of people here committing suicide, and we don't have anybody who lives in a big building committing suicide all the time. So is that an appropriate thing for your iPhone? Is that an appropriate cost for your iPhone? Are you okay with that cost, right? This kind of suicide cost. And if you're not okay with that, do you know who you could talk to about it? Do you know who you could yell at? Do you know who you could sort of punch in the face, right? I'll really talk about this punching in the face idea a lot. I love this idea that like you could shake somebody's hand or you could punch them in the face depending on how you feel about what they did in order to make the thing that you got. And I feel like it is a bold statement, it is a weird statement. I don't necessarily want to punch people in the face, but you should have the option, right? I think that that's a sort of a gauge of justice, right? Do you have the option to physically tell someone whether they're doing something correctly? The last cost is sort of this inhuman scale of the system. And this arises, again, because the infrastructure costs so much, so you have to put it centrally, so you have to move it out to somewhere, so you have to make a lot of, in this case, waste. This happened recently, maybe four months ago. This was in Hungary, a dam for a storage center for waste from aluminum production burst. And this is very alkaline, caustic material, sort of like drain cleaner. It's slightly different chemistry because it's red, but basically it gives you chemical burns in the same way. Damages your respiratory system, makes fields unable to be grown on, and this was like hundreds of millions of gallons of this stuff washed down the Rhine River, washed through this city. These people like woke up, in the morning to a flood of this sludge, like 4 feet tall, washing through their village. And they're just hanging out, right? Like these are not people that signed up for this kind of danger. And there are holding ponds like this all over the place. There are some in Canada that are capable of reaching parts of the US, especially when you could consider the watersheds that exist. We don't actually have, in the Northeast, you guys are safe safe, especially from aluminum production, because you don't have cheap enough electricity. In the Pacific Northwest, near Seattle, where I live, we have similar problems in British Columbia, so we could get contaminated by this kind of stuff. So this scale is just so big. We don't even know how to interact with it. It's so huge. 4 feet of sludge. What do you do about that? So these corrections, they usually call them corrections when one of these systems goes wrong. It's a correction, right? That is fundamentally sort of a cost that we can't afford to pay. But again, complexity has really serious benefits. We definitely don't all want to go back to being sort of Amish people, right? And that's always the example that people throw up. There are many different kinds of sort of low technology groups within the world, and we like the things that technology affords us, right? So we want to keep some of those benefits of complexity, and we may sort of have to keep some of those benefits of complexity. But we need to figure out new ways to get at that complexity. So I think that there are other sort of avenues to get you to complexity in more subtle, more human scale ways. Nature has figured out 1 or 2 or multiple avenues, and nature is actually still, much, much better at making complicated structure than we are. This is the surface of a wasp antenna. Each of these little spicules, these little kind of spiny hairs, are sensors. They're made out of chitin. They're like tremendously fine, and they're able to detect chemicals at levels that we can't even detect ourselves, right? So this is like amazingly complicated. We don't know how to do this. Nature figured it out. And the coolest thing is nature does it at room temperature in a bug, like with whatever a bug eats. It doesn't take a lot of energy. It doesn't take a lot of time, because the wasp only lives for like a couple of months. It doesn't take a lot of space. It doesn't take a lot of infrastructure. It is an amazing system. Now, if we could shoot for something like this, that could be interesting. But nature had like 3.4 billion years to figure it out. Fine. Okay. That's awesome. I submit that industry, the industrial system that we're sort of stuck with now, figured out almost all of its techniques within the last 150 years. This is Henry Ford, first assembly line to, your iPhone assembly line that they're always showing pictures of on TV, and Jonathan Ive is talking about how amazing it is. We've come that far in a remarkably short period of time. And if we could do that same thing with these intentional, small-scale, low-energy, like appropriate sort of human-scale ideals in mind, think of how far we could come in the next 150 years or in the next 50 years, right? We don't really need to change that much. We just need to sort of redirect our efforts in a more appropriate way. Is it possible to lower the cost of manufacturing without sacrificing complexity? So we don't want to go back to the stone tools, right? We still want to keep some of this complicated awesomeness, but we want to bring it back to a level where we can all interact with that manufacturing. I think that it's possible, and that's what I'm working on at the Humblefacture. The Humblefacture is my lab in Seattle. I say lab. I just want to sort of evoke the idea of an exploration space. It is a constantly experimenting place where I'm just testing out stuff that most people are not ready to touch. So I'll go through a couple of examples of sort of my idols out within the world, and then I'll talk about some of the projects that I'm working on. So this new idea of Humblefacture, right? Manufacturing where it is humble to you. I want manufacturing to respond to what you want, rather than you having to sort of like build your life around it, because you guys, you saw the picture of Foxconn with the nets, and you were like, crap, I really like my iPhone, darn it, and if you don't have an iPhone, it's probably just as bad with everything else. Like, honestly, this is not to pick on Apple, this is to pick on all cell phone manufacturers. It's it's part of it. You can't give it up, right? I mean, we know that you love your cell phones. That's fine. So we need to figure out another alternative way toward that. So it's got to be low energy. And here's an example of the Bamboo Bike Workshop. This is in Brooklyn, in Red Hook, actually. And they create bicycles from bamboo, from locally manufactured steel parts. They do use some steel parts, but they're all made in Brooklyn. And then they put them together, and you make a bike with your own labor. So this is one of the ways that they sort of like trickily did this, was that they don't use a lot of energy. Their energy costs are relatively low because they're using the people who build the bike, or who buy the bike, to build the bike. And so they don't pay for labor costs because the people build it as sort of a workshop. And they don't pay for energy costs because they don't have to do a lot of like TIG welding and that sort of thing. It's also a really nice space to be in. This studio is clean. You don't have to wear masks and stuff all the time. It is a really pleasant space to be in versus a metal manufactory, that kind of thing, right? It's also really convivial. So they get together, and it's like going to a wine tasting or something. You're hanging out with people who share your interests, building a bamboo bike, and have some common sort of camaraderie. And then the bike that you get in the end is a lot cooler because you built it, versus buying a bike from Walmart and then maybe you don't take as good of care of it as you might because you can get another one for $30 or $50. We need to get low-cost, small-scale infrastructure. This is really key. There are a few technologies that are much better at this, most of the fashion-centric technologies, because we still have small fashion houses working in the US. Particularly knitting machines are amazing. Like if y'all haven't ever used a knitting machine before, go find one on Craigslist. You can get them for relatively cheap. Especially on the East Coast, you can get them much more easily than I can. This is a Brother, I don't remember the model number, but it's a computer-controlled knitting machine, so you can actually hook it up to your laptop. And so this is somebody on Craft Magazine printed, I think this is Becky Stearns, printed a QR code on her scarf. So when you scan the QR code with your cell phone, it goes to her webpage. So this is crazy awesome. And the coolest thing is, once she gets this set up, she can crank these scarves out because it's a human-powered but computer-controlled machine. And so it allows for really flexible and really cheap. I mean, I think this machine you can get on eBay for like $300, right? So you make a $300 investment and you can be in business doing something. That's crazy, right? Like those of you who have tried to start businesses, depending on what you want to make, you may need to spend $10,000, $100,000. If you want to get into electronics fabrication, you may need to spend more than that. Another option is sort of flexible machinery. So you need to have low cost, but also flexibility. You want to be able to make multiple things. You want to be able to make things that respond to your user demand. And this is one example, is the Makerbot, which is a 3D printer kit that you can get for around $1,000 now. It used to be more like $700 or $800, but these are coming in so cheap compared to the next level up, which is like $15,000, that you could buy 2 of these and actually be printing at a relatively quick rate. But you can print like you print to a printer, to a laser printer, right? Where you can print multiple different documents. You don't have to make the same thing, like when you're injection molding with a mold that costs $100,000, you have to keep making the same thing over and over again. We need to have distributed designs. This is something that is difficult for people to get their heads around. It's really important that designs be shared, because most of the time, the design that you design will not be that useful for you in this situation locally. You will have 20 different ideas, and only one of them will actually be useful for your local situation. But 19 of them might be useful for someone else's local situation. And there's no reason for you to hang on to those 19, because you're not going to make any money off of them here, the way that you can produce them, but somebody else might be able to. And so it's this kind of idea that because the design, the information behind an object is easily spreadable, is easily shareable, then it should be shared. Because the matter is not, then the matter should be more locked down, and maybe people should make more for their local area, that sort of thing. So this is a scan that I had taken of my skull for, I did a project while I was in graduate school, and I had this skull 3D model, right? And I didn't know what to do with it, so I cleaned it up, put it on Thingiverse, which is a sort of like YouTube for objects, for object files, and I had 6 people around the world print it out. I think it's 8 by now. But this one guy printed it in aluminum. How cool is that? Like what other way would I get my skull made in aluminum than sort of by just giving it up to people and seeing, like, what are you going to do with this? What are you going to do with this file? And since then, someone has actually put on a better skull that prints better than mine, and so that's the one that most people make. But it's cool. I mean, that's the way that the system sort of aggregates upon itself. You need to have local feedstocks. So in the same way that you want to use local talent and local making, you need to be able to supply your materials from locally. In my ideal, this is my friend Joel, who's a really small-scale farmer in West Virginia. I would love Joel to be able to grow material as well as food for the farmer's market. And the reason that that's cool is because food and materials get used at different times. And they would allow a farmer to have a much more stable income instead of getting a lot of money in the summer and having to, save it over the winter kind of thing. You'd be able to smooth out your production and your income over the year. You would be able to have a more stable production. So in case, let's say that something doesn't do very well, your tomatoes or something like that, and you were counting on that income, you can still be covered by your hardwood production or your bamboo production or something like that. Maybe you're growing some kind of resin. So we need to develop these materials that farmers can grow that are valuable enough for them to grow. So there needs to be demand, so there needs to be designers making stuff, so we need to get all this sort of under control. You also need to serve local markets. So this is a friend of mine in Princeton runs an ice cream shop, and she is there in the store, and she knows what her customers like, and she pays attention to what her customers like, and she changes her designs of, sorbet based on that. She has 380 sorbet designs that, formula that she has come up with over the years, and she puts them in at different times of year because they use different local materials, local lavender, local corn, local sugar. She actually gets sugar from a mill in Philadelphia. So she's really engaged in the process, right? And she knows who her market is, and that's really crucial, and that'll sort of come back later on. So this range of needs opens a real interesting range of opportunities. Opportunities for materials. Now, these are all materials that other people are working on that I'm really interested to get in there and start working on. This is not a denim jacket. This is a jacket made from bacterial cellulose. So this is actually, if you ever made kombucha in your house, the mother of the kombucha is this sort of mat of a symbiotic colony of bacteria and yeast. And the yeast ferments the sugar into alcohol, and then the bacteria ferments the alcohol, or the bacteria digests the alcohol into carbon dioxide and cellulose. And so it poops out this little strand of cellulose at the end of the bacteria. And all of these little bacteria swim around and eventually form this mat of paper that is, it's paper, right? It's made of cellulose, but it is made of cellulose strands that are 1,000 times thinner than any piece of paper strand. And so this material has this incredible toughness and flexibility. But the coolest thing about it is you don't need any equipment to make it. You need a bucket, right? You take the kombucha mother, put it in a bucket, fill it up with tea, with sweet tea, wait for 3 weeks, come back, you've got a big piece of paper on the thing. And then you can dry it out, sew it. You can treat it afterwards. A friend of mine and I are working with, so this is by Suzanne Lee, as an artist in the United Kingdom, and a TED Fellow this year. Another TED fellow and I are working with her to sort of make different variations on this cellulose and try to make it more waterproof, more flexible, more all kinds of stuff. I really want someone, maybe one of you, to make a synthetic abalone nacre, which is the shell part of abalone, right? This material is just as tough as like ballistic ceramic, the stuff that we put on tanks to keep shrapnel from getting through. This is like incredibly tough material. And it grows, again, at ocean temperature on a snail, more or less. It is not a complicated thing to make. We just need to figure out that chemistry. And the difficulty is there aren't a lot of people working on this chemistry. They're working on this, like sort of decoding this material and trying to implement it using super high-tech ceramics, which you don't have access to the machinery to make. But if you could grow this material in the shape of a bike or in the shape of a car door, you know, wouldn't that be amazing? You have this like bulletproof car door that you grew in your garage. Incredible. This is another material that Eben Baer is CEO of this company called, wow, and I'm totally forgetting it, Ecovative Design. And Ecovative Design produces packaging replacements for styrofoam that are made from mushroom mycelium. So they take mushrooms, which is, it's not the fruiting body, which is the mushroom-shaped thing that you think of. Most of the mushroom is actually underground. It's these little sort of protein or chitinous rootlets that grow through this decaying matter, and they digest it a little bit. And so he puts a bunch of organic matter in a mold, like rice husk or corn stover or something like that, leftover agricultural waste, grows this mushroom through it, and then bakes it to kill the mushroom. And then he ends up with this very light, stiff, crushable, exactly like styrofoam thing, except it's biodegradable. It actually has the mushroom has already colonized it, so it's sort of like it's ready to degrade in your home compost pile. And it's fireproof, right? It's like has this fireproofness that styrofoam actually burns like crazy. If you can make napalm out of it if you soak it in gasoline. So and look that up on YouTube, it's really sketchy. But this stuff, you soak it in gasoline, nothing happens. It's fabulous. So the idea of mycelium composites, I would love to see you guys working with this stuff. Go get some oyster mushrooms, chop off the bottom, look up mycelium running oyster mushrooms. There's a file floating around the internet that shows you how to start an oyster mushroom culture and then grow it in coffee and then make this totally bizarre. This is another sort of material that I would love to see worked on. This is the equipment that it takes to make really high-grade optic fiber. If you wanted to, start your own fiber optic network and compete with Verizon Fios or something like that. This costs like a couple $100,000. You get started, you need a big warehouse space, you need a big glass furnace, you need all this stuff, right? There's a sponge that lives close to me called the Venus's cage, Venus's something. Venus's flower basket, that's what it's called. And it grows glass. It grows silica fibers that are as clear as optic fibers inside of it. It grows them. We're not really sure what it might colonize bacteria that glow, and so it attracts fish to come and swim into it and clean it out or something. We're not really sure why it grows this glass, but it does it, right? How sick is that? Let's make, why can't we grow windows? You know what I'm talking about? So we need to get this idea of culturing crazy materials. So my friend Joel can be not only growing, rice and peppers, but also weird glass vases in his farm in West Virginia. That would be amazing. Bioconcrete is another example where a concrete factory is this really big thing that you need to have, right, in order to make concrete. You can also make it by taking urea solution and this bacteria that creates a chemical called urease, which is it breaks down urea, and calcium. If you have calcium ions, so like Dasani with the calcium dissolved in it, so it tastes like minerals. You put the urea and calcium solution on some sand, and then you put the bacteria on the sand. And the bacteria will chemically react the urea with carbon dioxide from the air, lock it into the calcium ion, and create basically marble around the sand. So you end up with a solid brick. This was done by a woman, and I cannot remember her name, but she's the Metropolis Award winner for last year. Incredible work. She put this together, and you can make bricks with no firing at all. So no wasted energy. You grow this bacteria in a bucket in your backyard, right? Amazing. Finally, we need to think about new kinds of robots for making our stuff. I showed the MakerBot, right? This thing that 3D prints plastic. I showed the knitting machine that knits. Knitting is fine, but knitting is really good at making pictures on two-dimensional planes. It's not very good at making three-dimensional objects. This chair by Marcel Wonders, or this is a 3D crocheted sort of non-Newtonian surface that somebody made on Flickr. Both of these are tremendously complicated surfaces, right? These cool surfaces that you can make by adding knots in a string. And the problem with that is you need a skilled person to do it, and you need them to sit there doing it, right? If we could figure out a machine that could crochet, so this is all I'm asking somebody in the audience or in the internet, right? Make a machine that can crochet from a computer program. That would be insane. It would completely change the world. If you do this for like your, I don't know, if you're fibrous people, you do this for your senior project, you're gonna write yourself a check. Okay. We also need to think about the strategies we're using to make all this work, right? So instead of having one person making something far away and trying to make the right thing for every person in the whole world, which is sort of how we do it now, right? Jonathan Ive designs an iPhone, and it's the only kind of iPhone, and he does a new one every 3 years, but like, what are the chances that one iPhone will actually be the right phone for everyone in the world? It's just ridiculous. Instead, why wouldn't we do something like with tailors, where you have a suit that's sort of right enough, but then you have a guy who can tailor it, who can make it fit every person in the world, right? So you have this kind of mixed, centralized, and then distributed production. That could be pretty interesting. It would be also neat to have stacked production, right? So permaculture pushes this idea of stacking multiple different kinds of animal production on top of each other. You can see fish, vegetables, tree, fruits, chickens, all this stuff, and they all sort of contribute to one another. So we need to think about how can one industry provide wastes as feedstocks for another industry, and how can you build this sort of interconnected net within a city, because that's really the right kind of production for a city where people are packed together. You can have really interesting interconnected production. Finally, we need to think about new ways to make competition work, right? We need to compete on utility and not price. This is my bartender, Hideki, at Poppy in Seattle. He knows me, he knows what I like, he knows I'm gluten-free, so he can tell the kitchen to fix things on the menu if I order something without me having to talk to him about it. He also can say, hey, I know that you like, whiskey. I don't really like Southern Comfort for whatever reason he picked that out, but I know that you like this specific kind of whiskey. I made this new drink that I'm testing out. Tell me if you like it, and then he'll, I'll taste it, and then I'll say, oh yeah, I like it, or I don't like it. And I won't like punch him or slap him in the face, right? Or shake his hand, but it's the same kind of thing. It's a conversation. We're having a conversation about what works for me and what might work for other people. And through that conversation, he gets to be a better bartender. And most bartenders get to be better bartenders through that kind of conversation. Most designers don't get to be better designers through that conversation. And most manufacturers don't get to be better manufacturers through that conversation because it doesn't happen. So we need to think about how you're going to compete on utility, not price. You're going to compete on the fitness for you, right? Individual people or individual groups, rather than just saying, you know what, our price is low, so it doesn't really matter if it's right for you, it's just cheap, that's the only thing you care about. Try to get past the cheapness. So at the Humblefacture, I'm doing some projects that are trying to sort of like walk this talk, right? And trying to make this move forward in the present day. The first example is this kind of experiment for bending and binding. I'm taking bamboo that is grown on my property, and thread that I'm hoping to grow from milkweed or flax on my little plot of land in Seattle proper. And then I'm gluing it with a gum resin from cherry trees that are on my property. So everything is actually from like my block. And so I'm trying to make a chair. I want to get to the point where I have this like chair that's out of these pieces of bent bamboo. And if I was able to make that chair, I could have a chair factory in my block, and it would be extensible. So I could publish this technique, and anybody who can make a gum, thread, and some kind of bamboo-ish thing could make something very much like this, but appropriate to their local situation, right? So this is that hyper-local. I'm really trying for this hyper-local manufacturing. People could take it broader if they want, but I want it to work for a tiny, tiny space. I tried to think about how can you make open, modular, locally sort of appropriate designs with electronics, because electronics are one of those things that you probably have to make some of it centralized, at least for now. This is a watch that is fully open source, but it's actually designed by 2 people, maybe even 3 people. Bree Pettis, who made the Makerbot, designed this watch module, but he actually based it on the Maker, or the Arduino open source electronic module, which was built by Massimo Giussani, or I can't remember his last name. He's this wonderful Italian dude. So he invented that thing, and then Bree squished it into a watch shape and added some LEDs. And then I put this skeleton and skin around it, and then I published all of this stuff to Thingiverse. So if you go on Thingiverse and you search for Makerwatch SSG, you can actually make your own. Like, you can do it. You can find all of the files that you need to describe this thing, and they're all licensed under a Creative Commons share and share alike, but commercial license. So you're allowed to make this thing, sell it, do whatever you want, because I know that I can't possibly make this watch good enough that I could sell it to everyone in the world. But I do know that I can make it good enough that I could give it as gifts to friends, or sell it to a very tight-knit group of weirdos that I happen to know very well, right? And I would imagine that you guys have your own group of weirdos that you could make this watch into that would work for them, okay? This is a sort of more amped up version of the SSG, Skin, Skeleton, Guts concept, where this one uses an Arduino board. It uses some additional boards that are also open source and designed by a company, Liquidware, in Massachusetts, in Boston. And then my skeletal pieces, which are printable on a Makerbot, and my skin piece, which there's a template for it. So you can, again, take this whole thing and create your own stack. And this can actually run a very limited version of Linux. And right now it's just running a sort of a drawing program. You could turn this into whatever you want. I called it a tricorder because the tricorders on Star Trek, they can sense anything. And there's no way to really build an anything sensor unless you say, you know what, the Arduino, you can plug in any sensor that you want, and so then you can sense it, right? And so this is sort of extensible into whatever space you think is important. You want to sense like oxygen levels in your fish tank? Awesome, do it. Do you want to sense carbon dioxide levels in your greenhouse? Sure, buy a sensor offline and you can go for it. You want to sense the color of the paint that you put on your easel so that you can go match it at Sherwin-Williams? Great, set it up, share it, spread it around. This system for this SSG system is nice because of this modularity. So if one of you were to design a sensor module, right, for, let's say, this guy, you wouldn't have to sort of redesign the whole thing the way you have to do with like the iPhone because it's all integrated. You could design just the sensor module and then you could share just that module. And so this is a sort of an envisioning of how a cell phone that has these reconfigurable modules might be turned into an e-reader when maybe one of the modules breaks or you have to replace it, just by adding some a new skeleton and a new skin and a new screen, maybe a bigger battery. So you can change from the cell phone on the left to an e-reader kind of Kindle-ish thing on the right. For something very different. So I'm also interested in engaging people about the way things get made. So not just the way things get designed, but the way things get produced. And so this was a project that I did where I took a bicycle, put a sewing machine, a treadle sewing machine on the back, and rode it around to farmers markets around Seattle last summer. And I would collect scrap material from local producers to that farmers market. So I had some from printers, I had some from coffee roasters, I had some from some drapes that the woman who owned this is a wine bar that I went to and sewed little wine holders for people's wine growlers, these reusable bottles for filling up with like table wine. And so we made these things. This was a failed prototype because it's too short there. And the woman who owns the store came out and was like, "What are you doing? That's not going to be useful." And so it was cool. We had this conversation, and then she told me what was wrong with my design. And so then I fixed it in the later ones. So this idea of embedded manufacturing, not just hyperlocal, right, where I'm doing my thing within my community, but I'm actually doing my thing with my customers, right? That's a different way of engaging with people. I'm really trying to work on this outreach thing. I've been involved in the Open Hardware Summit. Wow, that's funny. It doesn't actually say anything about this. I thought I copied the right bit. I've been involved in the Open Hardware Summit. It happened last year at the end of the summer. There's going to be another one this year. And basically, this was the first one of its kind. We got together to try to discuss how is open hardware, where open source software has been so successful, how is open source hardware going to work? How do we describe objects in a way that's flexible, in a way that can be shared, in a way that can be built by multiple people? So I'm really trying to bring the materials conversation into that. A lot of it has focused on legality and on how do you describe the files, and I'm really interested in the materials. I really think it's crucial that we use materials that are locally available, materials that people can mess with. I also went to, as Ina said, I went to TED and tried to get people pumped up about this there, and I'm hopeful that I can continue to engage with that community and other ones to really try to push that idea that, this making is important. This materials aspect of your making is important. And finally, I wanted to talk a little bit about this bit that Ina and I are doing. This is sort of the next phase in this project. These are some of the materials that I presented to my students on the first day of class, and we're on the quarter system, so we've been going for 5 weeks. I have some images of what they've been working on, but I basically said to my students, look, let's make some stuff from within, we're doing within 100 miles of both of our respective cities. So Baltimore gets 100 miles, Seattle gets 100 miles. Both of us get a little bit of ocean, which is interesting. Baltimore gets a little bit of sort of quasi-mountains, but they're not really the mountains that we're used to out west. We get the eastern slope of a mountain, which is interesting because some different plants grow on there compared to on the western slope. We also get a little bit of Canada, so we can technically do hemp, which is awesome. So where you guys would have to be growing it sort of on the down low, this industrial hemp. And we can do all kinds of stuff. This is some again, that cherry resin. This is a burlap resin composite. We're looking at gourds, messing with gourds, bones, feathers, all kinds of funky stuff. And the students have just gone crazy. Like this is the crew there. They have brought in, well, let's see. So this was a coffee and biopolymer print. That's a piece of cedar. Miles wants to make sandals out of this cedar bark, which is a sort of a traditional Native American thing, but I don't know that he has the skills to do it. We will see. We're looking at, a lot of people are looking at bamboo. A lot of people are looking at like banana leaves, which apparently you can grow the banana in Seattle. You just can't grow bananas, which is interesting. Some people are looking at really a lot of stinky stuff. We've had a lot of like sea life. Somebody brought in jellyfish, somebody brought in seaweed, somebody brought in like skeletons of fish, and they're like, oh yeah, we could use this for, something beautiful, and it smells like awful. Poor Francis was like carrying around this rotting fish for a week and a half, I don't know. So it is a learning process. It is definitely a learning process. We actually had a sort of adventure. This guy, Magnus File, who's a faculty in industrial design with me, he recently bought a house, and he has this bamboo that's like overrunning his house. And so we went and did a sort of a horticultural adventure and chopped down some of his bamboo the other day, and you could see it was like a beautiful Seattle day with the rain. But this is the thing. This is what we need. This is what we need students to start doing, is to engage with the materials that you have, right? The materials that you can do things with. The biggest deficit, the biggest deficit that we've had is just not questioning the system, right? Remember I showed that picture of Henry Ford and the assembly line, 150, 200 years ago. That is what we just assume everything has to be like, and it doesn't. It's changing. We're getting more flexible, we're getting more connected, we're getting more nimble. We're getting better able to make real products on very small budgets. And if you look around at a lot of the cool projects that have been happening in the Make community or in the Kickstarter community, has some interesting stuff going on, there are people making real important contributions to the way we build stuff, and they're doing it with a couple of, tens of thousands of dollars or even thousands of dollars. And that was completely unheard of before. So now if we could get more people to start questioning those ideas and moving in better tools, better techniques, better materials that we could use to make sort of the next generation of materials, I think we could start making some real progress toward this goal. And I don't think it would take 150 years. I don't think it would take 3.8 billion years or whatever. I think we could make some serious progress toward making a humbler, localer, more human scale manufacturing happen within the next 20 years. Real change on the scale of a sort of a moon mission, that kind of thing. I think we could do similar stuff if enough people got behind it. So I do need your help. I need your voices, I need your input, I need your critique. You can read about the theory of this whole thing at humblefacture.com. You can look at what the Humble Factory is working on, what students in Ina and my class are going to be working on at humblefactory.com. And please, just get involved. I mean, the most important thing is to ask yourself, why was this thing made the way it was made? Why is this the way that we make stuff? If I could get more people to ask that question, I think we'd be much better off. Thank you all so much. Are there any questions? We have some. Yeah.
I think you have a great outlook on whether the future manufacturing possibly. Do you think there's enough individuals out there that you with these skills to make this sort of like homegrown manufacturing model so you can actually potentially overthrow like the master centralized stuff that's already in place?
That's a really good question. So the question was, do you think there are enough people with the skills and the motivation to sort of overthrow the man, more or less? I think I got two points to help with that answer, I guess. I think there are a lot of people who want to make, who are interested in making, and if you look at make.com or any of the Instructables, any of these sites that talk about making and the DIY culture and all that kind of thing, I think there are people who feel sort of like disconnected. We're so into this like knowledge worker thing that people are realizing that, like even just baking bread or something like that, I want to make something with my hands. I like working with my hands. So I think there are people who would be interested in being involved. I think the other thing that's interesting is that we've sort of lost the middle class of people, right? So I'm not talking about like everybody needs to be the guys who founded Google or something like that. I want to make technologies that are sort of turnkey, that will allow you to, like a bartender, like you be a middle class guy and start a bar, you get enough money saved up to like rent the space. From your local community that like this spot is a hot spot for like where people are at night and where people are moving. And so you start a place and you're like a personable guy, and you don't have to be like a techie wizard. I'm not interested in that. I'm interested in sort of this massive scale, filling in that missing middle class. I think that's a really crucial part. The other side of it, though, is you have to get back to that slide with the bartender where you're competing on utility versus price, right? And so if you compete on utility, it's most important for you to know your customer and to know who you're designing for, make something that is really perfect for them, right? When you're competing on price, you have to make so many of something that you have to sell to so many people that the best you can do is try to trick them into thinking that it's right for them. And that's what advertising is so great, right? In reality, it's not possible for Sony or for Apple or for whoever to design something that works best for you, because they actually never talk to you, and they can't talk to you because there's too many other yous in the world. There's too many other people in the world, right? I believe if we could get the technologies down to a small enough scale that we could get enough people employed doing this, I think that it would take care of itself. I think that utility would win out over price. But I think that you need to make it possible for people to make really compelling utility available. And that's the tricky part, right? Is making machines that are flexible enough that will allow you to, and I think it has to be machine driven, because you can't have, hand labor. You're always going to be shipping the hand labor off to somewhere where you can exploit people and make it cheaper. But if you can use a machine that can make multiples of something but make it flexibly so that you can change on your feet, then it's a lot more like a bartender, where you're a DJ. You're a person who's remixing and remixing and remixing this thing to keep it fresh and to keep it relevant. And there's no way that Sony, the reason that Christina Aguilera isn't a DJ is because she has to make a mass marketed, thing, and then there are a bunch of DJs that remix her into what people really want, right? So that's what I would like to see, is sort of, not so much Christina Aguilera and more of the DJ. Yeah, in the back. God, that is a great question. So the question was venture capital, what is the role of venture capital in the system? I guess, I have not really thought about this question exactly. So my perspective on this problem is that we would be able to, the system would be better if we could get the scale of sort of initial financial cost down to a smaller scale for the designer, for the manufacturer, for the producer. Where a venture capitalist would fit in there, I suppose, would be sort of like a, almost like maybe as sort of producers go in the music world, where they have sort of a stable of artists, and they're working with multiple artists in order to produce a sort of genre of music. I would imagine that venture capitalists might work in the same way, where they're interested in synergies that they can cause to happen within that space, rather than just being sort of loaded full of money and able to give one giant infusion of funds. I think that a venture capitalist role would be much more as a curator of synergies between different makers. So within Baltimore, for example, you might have somebody making, well, let's say that you're using 3 feedstocks, some kind of tree, some maybe bamboo, crab shells, I don't know why, and I don't know, you're growing some resin or something like that. You're going to get waste from each of those feedstocks. And if you're a savvy entrepreneur, you're going to see the connections of that waste and where a new company might be able to build off that waste. Does that make sense? So you have a much more active role, I think. I think the days of sort of the entrepreneur who's just like, I like tech, and just give to tech people, or I think I think that your tech idea is shiny. I think that's sort of over, and you got to be a lot more involved in the synergies of the world. Yeah.
I think maybe where the capitalism come in, I think there's a, somewhere around San Francisco, there are these sort of large like factories with all this equipment in it might cost like a couple $100,000 to equip, but then everybody.
Right, yes, like tech shop, the tech shop people or other kind of tool share people.
I mean, I think that that's an investment that.
Absolutely.
Capital that people could access. And we have something here now like Fab Lab at Community College of Palm County that provides access to that kind of equipment at a pretty expensive cost on a global scale. It may be the replication so that more communities.
Right.
Markets have these tools to do these smaller scale things.
Right. Yeah, I think the tools really key. Another part, though, I think it comes to those techniques, right? So one of the things that is a stumbling block for small scale fabricators is how do you fund developing a new technique when you don't have a ton of money, right? That generally gets done by big companies who have R&D departments and that kind of thing. I've sort of worked around it by trying to have this decentralized R&D by everybody sharing all of their designs all the time. And so collectively, we grow as smart as IBM or whoever. That might not always work because there may be some avenues that are so, they're such long-term avenues that you really do need some incentive to go down that road. And that might be another place where a funder could sort of intervene or interact. Yeah.
Can you talk about how our relationship with the world
I have. And the exciting, for me, probably the most exciting thing from a whole world perspective is that this ideally, okay, if all this works out, this sort of obliterates, other than the internet, access to the internet, which we still will need to figure out how we can spread that access to the information, because information, again, like information behind complexity is sort of like the key to making this whole thing work. Being able to share that information, being able to share techniques, being able to share 3D fabbable tools that are open source defined tools that somebody can like download the plans for and then make stuff with, right? That web side of this thing is a very important equalizer to the world, and I realize that that gap is still there. But we're working on it. That part is coming down. Once this idea gains hold, I don't see there being a lot of difference between the developed and the developing world, because you don't need big infrastructure in order to make things, right? And the part of the reason why the developing world generally exports all of their raw materials and the developed world, complexifies those materials and then sends them back is because we have the infrastructure built up. There's a momentum of infrastructure. If you don't need a lot of infrastructure, or if that infrastructure can be fabricated from a file, then it invalidates that imbalance, I guess. The other thing, though, that I think is more exciting is that a lot of the developing world is smarter about this stuff than we are, because they're still in that space. A lot of them are still working with very relatively raw materials that are locally sourced because that's what they have access to. And the only way that we're going to retain that knowledge globally before you sort of have the McDonald'sization of the world, right, where everybody is adopting, or not everybody, but a lot of people are adopting this sort of Western mindset where they're going to start to use plastics instead of stuff. There's a beautiful book called How to Wrap 5 Eggs. You gotta check it out. It was made by a guy in Japan in the 70s when they used to actually use farm-based materials like straw and stuff to package the material from the farm. It's a wonderful, wonderful idea. Most of this packaging has left. It is not used anymore in Japan because it's cheaper to use, styrofoam or molded paper or this kind of stuff that was developed in Chicago to ship to the United States. And that's fine, but that knowledge is lost. And someday, maybe, we won't be able to make styrofoam as easily as we could make straw. And if we had that thread of technology that has been sort of snipped off, if we still kept it somewhere, and if we allowed those developing sort of partners to add to this knowledge base, this global cloud of possibility, then I think we could, you just have more diversity to play with, and you're more resilient in the case of, say, oil becomes too expensive, right? You have a lot more options to play with. So I think that the third world is a key player for the developing world, or whatever you want to call it. Yeah. Yeah. Right. Right. Yeah, and they're fabricating the metal pieces in Brooklyn, shipping a container, basically a shipping container full of them to Ghana, where there's another bicycle factory in Ghana that uses local labor, and all the money for that value add goes back into the local economy. And so it's just a very different model for, how you take advantage of the infrastructure that's here, but then sort of build up value there. Yeah, exactly. Exactly. Any last questions? Yeah, Dave.
Are you aware of any of the East Coast examples of this kind of stuff in Baltimore?
Good question. Yeah, we are it. So the Bamboo Bike guys are definitely worth checking out, and I can send you their contact information. There are a couple of guys in Philadelphia. I'll have to connect you with my friend Andrew Dahlgren. Is very sort of keyed into the Philadelphia area scene for local manufacturing, and so he knows most of the small-scale manufacturers in Philly. Not as many of them are interested in local feedstocks as he would like, and so he's trying to get some brownfields converted to, like vacant lots basically, converted to grow feedstocks for something. And I think that's going to be the first step, is when people start to grow materials in cities. And really, I mean, it's like the production cycle, the bike with a sewing machine on it. When you pose people with the question, why do you not know anything about any of the material that you're getting to make stuff out of? Why do you not know? Then they start asking themselves that question, and then it starts, you start getting this interesting conversation. Until you ask that question, it's just assumption all the way down, right? And if, I think that people who start growing stuff in cities, that's like a provocative enough idea. And it works in cities like Baltimore, and not so much in New York because prices are so high for land, but Philly and Baltimore, you guys got tons of space, right? Philly's got like 40,000 vacant lots or something, the last count. Go for it. And that's actually one place where city government can play a real role, because you can add value to those plots. You can stop the gap tooth kind of whatever it's called, bucktooth house problem, and really get some momentum building in your neighborhoods. Yeah. Oh yeah.
Are there one or two feedstocks that you would say are, like, I like this idea of, I know bamboo is very, used for a lot of different things, but are there, one or two, like, sort of key, you're just starting out, or you just wanted to, like, have something mess around with, or what are some really flexible or...
Yeah. That's a really good question. I would say my favorite three things right now are the kombucha paper. I am so keen on that stuff. That is bizarre, completely insane. You can grow it as big as you get a kiddie pool, like get one of those big 5-foot kiddie pools. I want to see somebody covered in like a Pac-Man ghost of kombucha paper. And this stuff is so mucilaginous and gross when it comes out of the thing. So just be forewarned. Go watch. Suzanne Lee has some amazing videos that were produced by the art museum in the UK, and they're beautifully done, and she's really articulate. She's a great speaker. So that stuff, awesome. Go get on Craigslist and get a mother. The other thing I would say is y'all should know how to sew. Get a sewing machine off of Craigslist, break needles, try sewing through, how much paper can your sewing machine sew through, right? Like I have 8 sewing machines, okay, I'll admit it. One of my sewing machines, which is this old, like a 1591, is this one that Singer made for a while. It's great, it's burly, can sew through like literally a 1/4 inch of paper, like printer paper. You can make books, just chonk, 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 just sew right through it. Use a sewing machine, mess with a sewing machine, learn what you can do with a sewing machine. You can do much more than people do with these machines. And then the last thing I would say is, explore resins, play with resins. There are not very many good resins out there for messing around with, and we need more people experimenting with what things you can sort of like boil down or goop up or whatever. There's a very interesting video. If you look up Mongol bow, MONGULGOL, like the Mongol hordes, I don't know how you spell it. Look up Mongol bow on YouTube. There's like a 3-part video. It's all in Korean, so you're not going to get anything out of it, except visually, they show you how to make one of these recurve bows that like conquered Asia, right? And it uses horn, and it uses a glue made from the fish bladders, the swoon bladders of this bass. That was like these two technologies. You're making a horn bow with the fish bladder with tendon. It's completely changed the world, like literally changed the world. Like these guys took over the world as they understood it, with fish bladders, okay? You gotta mess with that stuff. You guys live near the ocean, right? So you should be going and boiling down every kind of animal that you could possibly find in the fish market, right? Like, I don't know, fish bones, maybe they boil down. I don't know. Look up old glues, ancient glues, hide glues, rawhide, I don't know. Play with stuff, get dirty, yeah. There is not. No, there is nothing like that. I wish that I were answering this question in like 5 months, because there will be something like this soon enough. Yeah, but it does not exist yet. Oh, good question. The cherry trees that I was using are a wild sort of native cherry. And they're it's just oozing out of the tree all the time. It's goop all over the thing, and you just like pick it off. It's beautiful. If you have a more ornamental one, there might be less. I know that some students tried to get them off the trees at University of Washington, which are these like big old Japanese cherry trees, and they grow much more slowly than these ones. So if you go find you may have to actually go out into the woods and find a cherry tree, but there should be goop all over it. It was my experience, was that it was just like, I got actually like, I don't know, a liter of goop from one visit to 5 trees or something like that. Yeah, so I think it's on Scribd. Do y'all know Scribd? Is this like YouTube for documents kind of? If you search for violin making, as it is and was. I think it may also be on Project Gutenberg. It's a treatise that this dude wrote in the 1800s based on a treatise from the 1500s, and he goes through all these recipes for varnishes for violins, and he talks about how you process gum rosin. They called it gum rosin or cherry gum. There are some other. If you look, you look online and just search for those terms, but that's the best one I've found is violin making as it is and was. Yeah, you gotta boil the stuff for a while and then put it through a blender and then strain it, but you'll figure it out. All right. Thank you guys so much. This has been really fun.